Hello all, welcome to this YouTube channel. Today we are going to be tackling the topic of numbers, and we are going to be basing the topics of Edexcel's specification of what you need to know about numbers. So the aims of this video is to understand positive and negative numbers, understand decimals, and understand fractions. So hopefully you would have been familiar with positive, negative numbers, decimals and fractions, but the aim of this video is to really make sure you understand it. So hopefully you're already familiar with positive numbers. As the number increases, so does the value. 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2, and so on. It increases in value as the number increases in magnitude or size. However, with negative numbers, it's the reverse, because it's negative. On the red side of the number line, or with negative numbers, as the number increases in size or magnitude, the value decreases. So -1 is actually bigger than -2, and -2 is bigger than -3. So it actually works in the opposite direction as positive numbers. Here is this arrow showing you that as you move from the left side of the number line to the right side of the number line, the values of number increases. So which number is bigger, -2 or 7? Right, 7. 7 is a bigger number because it is positive and it also has a bigger magnitude. Okay, so which number is bigger here, -9 or 3? Right, it's 3. 3 is smaller in size, but it's positive, and so it's bigger in value than -9. So which number is smaller, -34 or 14? Right, it's -34. Even though it's bigger in size or magnitude, it is smaller in value because it's a negative number. Which number is smaller, -19 or -2? Right, -19. Even though it's bigger in size and magnitude, it's actually smaller in value. Think about where it would be on the number line that I showed at the beginning of this video. Okay, let's move on to decimals. Before we do that, let's quickly revise place value. So we have the number 434. It has 4 units, 3 tens or 30, and 4 hundreds or 400. We know this just by looking at the number in each column. Okay, let's try a number with decimals in it. So we have the number 156.217. So we have, at the top of this table, we have what each column looks like. So this is what 1,000 looks like. This is what hundredths look like. This is what 1/10ths look like. This is what 1 units look like. This is what 1/10 looks like. And this is what 100 looks like. So the number at the bottom shows how many of each column we have in this number. So in this number, we have 100 that we can tell just by looking at the hundreds column. We have 5 tens just by looking at the tens column. We have 6 units just by looking at the units column. Then we have a decimal point. We move on to the next column, the tenths column. We have 2 tenths or 2 0.1s. We have 1/100th. This is what 1/100th looks like. We have one of them. And we have 7 thousandths. So we have 7 of them. This is what one of them looks like. So this is it all written out. And when we add all of these together, we get our number 156.217. So in other words, we've just deconstructed this decimal into its place values and columns to understand it better. Okay, let's try another example. So we have the number 8,434.392. So let's do what we did before, split it up into its respective columns and decide just by looking at where each number lies, how many of each column we have. So we have 8 thousands, 4 hundreds, 3 tens, 4 units, 3 tenths, 9 hundredths, and 2 thousandths. So if we were to add up each of the respective columns, we'll just get the original number, 8,434.392. Okay, so before we go into ordering decimals, let's try and recall how we order numbers, whole numbers. So which number is bigger, 17 or 90? Hopefully you know it's 90. The way to really figure this out is by looking at each of the columns. So when we're ordering numbers, you have to start with the column on the left, or the column with the bigger value. So we first look at the tens column of each number, because this is the bigger column. We compare the values in each of the numbers in the tens column, and we can see that 9 is bigger than 1. Because we already know this, we already know that 90 will be the bigger number without looking at the units column. It's important that you look at the column on the left first. That is how you order numbers, whether it's whole numbers or decimal. Okay, so which number is bigger, 1.26 or 0.87? Remember, look at the column on the left. So the column on the left is the units column on both numbers. So we can compare the units column and we can see that 1 is bigger than 0. So because of that, we know this number, 1.26, is actually bigger than 0.87. We don't actually need to continue looking at the other columns because the column on the left is bigger when comparing the same column. Which number is bigger, 5.32 or 5.92? Remember, we start off by looking at the columns on the left. So the columns on the left for both number is the units column. Both of them have 5, which are equal in value. Because they're the same, we move on to the next column. Okay, so the next column for the first number is the 3 in the tenths column. The next number in the tenths column has 9. So we compare 9 to 3. Which number is bigger? 9. So 5.92 is the bigger number. Okay, what number is bigger, 1.09 or 1.2? Remember, we start off by comparing the values in the leftmost column. In both numbers, the leftmost column, which is the units column for both numbers, is 1. They're both equal, so we move on to the next column, which is the tenths column. Comparing the tenths column for both numbers, the first number has 0 in the tenths column. The second number has 2 in the tenths column. Since 2 is bigger than 0, we know 1.2 must be bigger than 1.09. You don't need to continue looking at the number, and we don't need to worry about this 9 because the column on the left, which is the tenths column, is bigger in this number, 1.2, than the first number, 1.09. So remember, always start from the columns on the left. What number is bigger here, 0.48 or 0.84? Okay, the answer is 0.84. So just like we've done before, we start off with the leftmost column. So this will be the units column. In both numbers, the units column is 0. So you can't choose which number is bigger. So we move on to the next column, which is the tenths column. So I'll be looking at the 4 in the first number, and I'll be looking at 8 in the next number. So what number is bigger between 4 and 8? 0.84. So this will be the bigger number. Okay, let's move on to the next topic, fractions. So what is a fraction? A fraction is a part of something that is whole. So over here we have parts of an apple. It's been bitten into even a remaining parts to it. This is the whole apple on the right hand side. The left hand side is a part, the right hand side is the whole. So this is essentially what a fraction is. It's a part of a whole, except in maths we use numbers instead of apples as like. However, when it comes to fractions in maths, there is one special condition. In maths, when you're trying to represent a fraction which is part of a whole, it has to make up the whole in equal parts. So for example, we have this part of a circle, and this is a fraction of the whole circle. How comes it's a fraction of the circle and not just a part? Well, it can fit equally into the whole circle, so it makes it a fraction and not just a part. This, on the other hand, is a part. It can fit into the circle, but it won't fit into the circle in equal parts, so it's only a part. The apple that's bitten into is a part of the whole circle. This chunk of the circle can fit equally into the circle, so it's a fraction. So how can we describe fractions? Now we know what a fraction is. How can you describe the different types of fractions? So if we look back to that same example, the part fits into the whole equally 4 times. So this is described as 1/4. So 1 out of the number of times you can fit into the whole, or a quarter. Hopefully you're already familiar with this term. So this is the whole, and the quarter, or the chunk we referred to in the previous slide. This can fit equally into the whole chunk 4 times. There's only one of it, so there's only 1 out of 4. Hence 1/4 as a fraction.